This is section 12.4, present value. We're going to be solving for present value now, and you want to make sure your calculator is set on 2 decimal places. Remember, you can reset your calculator, or you can use the second format, which is second decimal place, put a 2 in, push enter. Okay, or a reset. It's good to reset sometimes. Okay, I'm trying to advance. Here we go. Since money earns interest over time, then money invested in the present value will grow to a larger amount in the future. So future value is more than present value every time, and present value is less than future value. So I'm hoping that this will seem logical to you, that if we invest the money, present value, it grows to a larger amount, future value. When it comes to, that should have an S. When it comes to entering data in your calculator, which one is negative? Well, present value will be negative because that's going to be an amount put into an account. Future value is positive because when it grows to a certain amount, then we can take that money and spend it. So if we have it in hand, that's positive. All right, here's our first example. Your grandfather tells you that he's going to give you $5,000 for your college tuition 6 years from now. All right. In 6 years, you're going to get $5,000. So think about that. Where's that $5,000 going to go? How much is that money worth today, right? How much is it worth today? That would be present value, right? Present value. If he's able to earn 4.83% interest compounded quarterly. All right, so it may seem a little weird at first as you start setting these up, but if he's going to give you $5,000 in 6 years, then that is our future value. Remember, it is positive. So you just put in $5,000 and you don't have to put a sign because it's already positive. We are not making a payment. All right, so we're going to put a 0 there. All right, so for 6 years, compounded quarterly, we're going to have a 24 periods, right, in this account. And then our interest rate will be divided by 4 because it's compounded quarterly. So we divide by 4. Don't forget your equal sign before you press your IY key. And then our present value is actually what we're going to compute. So we will compute present value and figure out what this has grown to, or what this amount was that grows to $5,000. I don't want to say that incorrectly. Okay, so you put your numbers in, make sure all your categories are filled in, and you simply compute present value. And on your screen, you should have the negative, right? Because it is an amount that's put away into an account. And this is what we get once we have computed this, $3,748.57. So basically we're saying this $3,748.57 will grow to $5,000 in 6 years. That's what that's saying. Okay, let's look at the next one. Your daughter's college fund consists of bonds which will mature in 11 more years. Their promised maturity value totals $45,000. Okay, so we are here at, we're going to have 11 years. Their promised maturity value, remember maturity values at the end of a loan, so that might help you realize that the $45,000 is going to be our future value. All right, that's going to go in for future value. If the projected earnings of the bond is 5.25% compounded quarterly, how much are the bonds worth in today's dollars? So that's my present value, right? 5.25% compounded quarterly. So let's fill out the chart. All right. 11 years. I circle or underlined that up there. 11 years times 4 equals, so 44 times it compounds, and that's how many periods we have for this particular question. And then our interest rate is 5.25%. We're dividing that by 4, and you push your equals key. We are not making a payment. It is a one-time deposit. Okay, so it says how much are the bonds worth in today's dollars. So in other words, when you buy bonds, you pay a certain amount, and then that grows until the bonds mature, and then they are worth more money. So your present value is whatever they're worth today. Okay, so we are computing present value. All right, we want to compute. And so that amount, remember, you can pause so you can try this yourself. It's going to be $25,353.57. And don't forget that that is negative because that's money that we don't have our hands on, right? We can't spend it. It's not in our hands. Therefore, we put it in as a negative. All right, here's the next one. This one's a little bit different. You've been selected for jury duty. A very talented young dancer lost her leg in a car accident that was not her fault. You and your peers found for the dancer must decide what amount she should receive as a settlement. Okay. Previous to the accident, she was able to earn $38,000 net income each month from her performances and would have been able to continue for another 27 years. Assuming that the money is worth 8.5% compounded monthly, whoops, I don't want that in the way. Compounded monthly, what is the possible settlement amount? Now this wording might seem a little weird and strange to figure out what goes where. And I understand that, and that's why you want to practice so that you do know what to put on your chart. Okay, so let's just start with the years. It's 27 years. Compounded monthly means we'll multiply by 12 and push equals. That number goes on your calculator for N. So remember, get it on your screen, push N. The interest rate is 8.5, and we divide that by 12 and push our equals key. So that goes in for I. There is no future value for this money, right? We're currently just trying to figure out what payment she would get, or how much money it's worth for the payment that she's going to get. And remember, it was possible that she could earn $38,000 every month from her dancing. Okay, so she's getting a payment. That's what we're looking at. If she's paid a payment of $38,000, basically how much money do we have to have in the account to support that, right? So that there's money to pay that. We are going to compute present value, right? So we're going to put a circle for this one. It's not really a circle. I guess I shouldn't call it a circle. Whoops, how about 2 circles? I'm going to get that in there eventually. So this is what we compute. Now, $38,000 per month, that's a lot of money. So her settlement amount is basically enough to cover that so that she can withdraw that $38,000 every month for 27 years. So that amount it comes out negative, remember, because it is going to be in an account. It is $4,819,759.84. So that would be a nice amount to have sitting in the bank for sure. All right, let's see where we are on time. I think we're going to try one more. Okay. All right. Cutie Pie plans to open a savings account. She will deposit $100 every 6 months and would like to know how much to deposit when she opens the account to end up with $7,000 in 15 years. The account earns 3.06 compounded semi-annually. So when it said she was making the payment every 6 months, it's a semi-annual payment. All right. And she's doing this for 15 years. She's going to end up with $7,000. Oops. She's depositing $100, and that is semi-annually because it's every 6 months. All right, so we have 15 years times 2 equals, so that'll be 30 periods for this particular question. Her interest rate is 3.06. That will be divided by 2. Don't forget to push equals and then push your IY key. Her payment amount is negative $100, right? Because she's paying that in, so therefore it's negative. Future value is positive, and it is $7,000. So we're trying to get this account to end up at $7,000, and we need to know how much is she going to put in the bank, as well as let's see, where does it say? How much to deposit when she opens the account, as well as making that $100 payment every 6 months. Okay, so we're going to compute present value, and that's going to tell us how much to deposit in this account so that she can end up with her $7,000 at the end of this period. And this is how much she needs to deposit when you... Oh, I didn't mean to zoom that. Come on, get back in there. It's going to have a little black thing around the edge. She would need to deposit $2,047.41. And of course, she's also making that payment. All right, well, I'm going to end this video, and then I will finish 12.4 on the next video.